Hello everyone, Dr. Vaughn. I'm going to record this video because I'll make an announcement in class, but they moved my flight up, which was scheduled for 11 o'clock departure, and I was going to be able to teach class just fine. They moved it up until a 7:40 departure tomorrow morning, and there's absolutely nothing I can do about it. So I'm going to try to be on in the morning and then also at 9 o'clock from the flight, actually, if I can get a strong enough internet signal, but I'm not counting on it. So like I said, I'll put this into an announcement, but I'm going to record some videos here that you can watch because I don't know how long I'll be able to stay in the classroom tomorrow. And then Friday, for sure, I won't be there. And I have another video, which I'll go over the quiz for this week, and we'll do a preview of the following week and, a couple of other things. So Friday, you don't have to come on Zoom. Tomorrow, try it. See if I'm there, but if I'm not, I would just kind of watch this video and not stick around too terribly long. All right, so anyway, what I wanted to go over with you is the last few topics from topic 4 that we didn't have a chance to talk about in class last week. And this is fraction to decimal conversion, and then we'll do decimal to fraction conversion, and we'll end with just a brief discussion about square roots. So first we're going to start with fraction to decimal. And there's some easy cases, and those easy cases are things that you just kind of use so frequently in your life that you might just be able to convert, offhand. And an easy example of this is 1/2. 1/2 is 50%, 0.5. 5 out of 10. So the 0.5. So converting 1/2 to a decimal is something that you don't really have to have a calculator or pull out a pencil and paper to do. You just know what it is. A lot of people, especially if you're of adult age or if you've been teaching for a while, know how to do 10% of something. And that's the same thing as 1/10, right? So if I had something like 3/10, that would be 0.3. 20% is 0.2, 2 out of 10. 3 out of 10 is 0.3. So the tenths are kind of easy. 1/4, a quarter. A quarter is 25 cents, 0.25. Now, this one, maybe not everybody knows. 3/8 is one that even if you don't know it, you might be able to figure it out without doing something incredibly complicated. The way you could do that is you could take a quarter, which is 0.25, divide it in half to get 0.125. That's 1/8, and then do it 3 times. So twice would be 2/8, would be 0.25, and then add another 0.125, that repeated addition model, and so you can get 0.375. So again, that's not one that, somebody just asks me and I can rattle it off with a cuff, but it is one that if I just pause for just a minute and think about it, I can pretty much figure out. 1/3, 0.3333, or 33 1/3%. When we put this bar over it, we'll talk about this a little bit more to denote that this pattern repeats forever. It doesn't stop. It's 0.333333 without ever ending. The next case that I want to talk about in part B are also fairly straightforward, and these are when you have powers of 10 in the denominator. Some examples here, 6/10. And the reason why these are easy is because when the denominator is a 10th, a 100th, or a 1,000th, this corresponds to place values on the right of the decimal in our decimal system. So a 6 in the 1/10th position, 0.6. 37 in the 100th position, 0.37. And 943 in the 1,000th position, 0.943. And you don't even have to fill up all these digits. You could have a 0. Like I could have, let's do 37 over 1,000. What I'm going to do is go to the 1,000th position and put 37 as far to the right as I can. And then I'll just have to pad this with a 0, so 0.037. So when the denominator is a power of 10, you just take the numerator number and you just need to worry about placing the decimal point accordingly, right? And it's the number of zeros that tell you how many times to move the decimal. So 37 over 1,000, I could start with 37 and say 3 zeros. So I move this 1, 2, 3 times, and that's another way you can get that 0.037. The number of zeros is how many times to shift the decimal point left when you write the number that's in the top, the numerator of that fraction. So those are the easy cases, A and B. Things you recognize or things that are powers of 10 in the denominator. In the more general case, there isn't an easy way of doing this. There are some tricky ways that are almost not even worth telling you about. So for example, on 3/20 here, you can multiply the top and the bottom by 5 to create a power of 10, which is 100. And then I'd have 15 over 100, which is 15 hundredths, which is 0.15. So I can kind of figure this out when I can create a power of 10 in the denominator, but I need to figure out what to multiply by to create that power of 10. And in those cases, when this can be created into a power of 10, that's when you know that the decimal is going to terminate. It's going to stop. Because it stops if and only if it can be written as a power of 10. Now, it might reduce to something else as a fraction, but in its decimal form, it's going to terminate when it's over a power of 10, as we just saw up here in part B. All right, so I don't really want to take that approach here. I don't want to take the approach of trying to figure out if I can turn this into a power of 10, but the more general approach here is just to use long division. And you're going to long divide as much as you need to until the decimal either stops, meaning you get 0 remainder, or it starts repeating itself. So I'm going to do both of these examples, 3/20 and 4/7, but we're going to do them on a new screen so that it doesn't get too crowded. We'll start with 3/20. So 3/20, I'm going to take the 20 and divide into the 3. So the 20 is going to go outside, the 3 is going to come underneath, and I'm just going to put a bunch of zeros, and I'm going to start dividing. Now, notice the decimal point here is already at the end, so this decimal is already appropriately placed, and now I ignore the decimal point. 20 goes into 31 time, multiply, and subtract. Bring down the next 0, 20 goes into 100 5 times. 5 times 20 is 100. And now I get 0 remainder. So everything else is going to be a 0. In other words, it terminated. That's my answer, 0.15. Right, so that's a terminating example. I got a 0 remainder, and therefore I knew that I was done. All the rest of the bring downs are also going to be 0. Now compare that with 4/7. So when I take, this cannot be turned into a power of 10. But even if you don't know that, I'm going to do the same thing. 7 goes into 4. I'll add the decimal point and just add a bunch of zeros and start my division process. Now 7 goes into 40. Okay, let's place that decimal point. 7 goes into 40 5 times. That gives us 35, and I'll subtract. I'm ignoring the decimal point. That gives us a remainder of 5. Bring down the next 0. 7 goes into 50. Well, that's 7 times, because 7 times 7 is 49. Subtract. That leaves a 1 remainder. Bring down the next 0. 7 goes into 10 1 time. That's 7. That leaves a 3 remainder. Bring down the next 0. 7 goes into 30 4 times. That's 28. Subtract. That leaves a remainder of 2. Bring down the next 0. 7 goes into 20 twice. That's 14. Remainder 6. Bring down the next 0. 7 goes into 60. Well, 8 times. That's 56. And now I get remainder of 4. Now, at this point, I can stop, because when I bring down the next 0, I have 40, which is how I started off this whole process. 7's going to go into 40 5 times. So now my remainders are just going to continue in this same pattern as when I started. So I'm going to get 5, remainder 5. Bring down the next 0, I'll get 7, remainder 1. Bring down the next 0, I'll get 1, remainder 3, etc. So 0.571428.571. So this pattern repeats itself. 0.571428. You have a 6-digit sequence that now is going to repeat itself over and over and over again. And so this is an infinite repeating decimal. And you get it by doing long division until you see that it either terminates or repeats. A number of digits that repeat is called the period. So this has period 6 in its decimal expansion. So before we go on to the other way, the decimal into fraction conversion, I just want to look at Alex for a moment and go all the way back to question 13 from your homework. So question 13 is one of those case B, 87 over 100. So all I need to do in my case is write the 87 and then divided by a power of 10, 2 zeros. So I'm going to move this 1, 2 places, place the decimal point, and write 0.87. All right, then we got into all of these, equivalent fractions that we talked about earlier this week, all the way until we get up to about question 30, which had to do with just powers of fractions. And then 31, where we start writing it as a mixed number. And 33 is now converting a decimal into a fraction. What we've been doing so far is turning a fraction into a decimal. So let's tackle this next topic, a decimal into a fraction, as we're finished with fractions going into decimals. All right, so now we're going to look at decimal into fraction. And I'm going to break this down into 3 cases, really 2. But the first case is going to be where the decimal terminates. The decimal terminates. It ends, which is the case with our example over here in Alex, 0.23. There's nothing else after that. It ends at the 3. So let's use this example from Alex, 0.23, to explain the process. And that is, it's just the opposite of what we did for the fraction into decimal, where the denominator of the fraction was a power of 10. Here, we're just going to appeal to place value, tenths and the hundredths digit. And I only need to look at the far most right digit. So I can count 10th, 100th, and I'm going to put the entire number over that denominator. So I'm going to take, for 0.23, I'm going to take the 23 without the decimal and count over 1, 2 places. So I'm going to put it over a 1 with 2 zeros, 100, 23 over 100. But here's the thing, make a note to yourself, reduce if necessary. In this case, 23 and 100 are relatively prime, meaning they share no common factors, and therefore this fraction cannot be reduced. But consider the example of the terminating decimal, 0.25. When I do the same thing that I did in the previous example, I'd get 25, ignore the decimal, now count 1, 2 places. So 1, 2 zeros, 25 over 100, and this fraction can be reduced because I can divide the top and the bottom by 25. and get that simpler fraction, which is equivalent of 1/4. Right, so if the decimal terminates, we're going to use place value to put it over the appropriate power of 100 and then reduce if you can. So that leaves the what happens then if the decimal does not terminate. Well, if the decimal does not terminate and does not infinitely repeat itself, then it's an irrational number, which means, we'll talk about this next week, which means that it doesn't actually have a fraction representation. So case 2 is going to be those decimals that repeat. They have a repeat end. They have a portion which infinitely repeats. Now I'm going to do a couple of examples of this, and then we're going to jump in and look at the remainder of the homework in ALEKS and finish by talking about square roots. So the first example I'm going to do is 0.8 bar. So here's what you want to do with these, and it's a little tricky at first. Right? So I'm going to call this the letter S. You can use any letter you want. And then I'm going to multiply by the power of 10 that corresponds to the period. The period is the number of digits that repeats. So this has period 1. So I'm going to multiply by 10 to the 1 power. I'm going to multiply on both sides. So I'm going to get 10 times S equals, and when you multiply, this is 0.88888888. When I multiply by 10, that shifts the decimal over one place, and I'm going to get 8.88888888. Okay, so that's step 1. Step 2 is I'm going to subtract the original expression. So I'm going to take S equals 0.8, and I'm going to subtract S, and I'm going to subtract 0.8 bar. What multiplying by the period, 10 to the power of the period, did is it lines up these repeating parts. So when you subtract 10S minus 1S gives you 9 S's. And over here, 8 point, and then the repeating 8s, minus 0 with the repeating 8s. The repeating 8s all cancel each other out, leaving me just the 8. All the repeating parts are gone. They canceled each other out. So now I can just solve for S. By dividing both sides by 9. And the equivalent fraction to 0.888 bar is 8/9. All right. So I said we're going to do one more, but let's, for the sake of time, do one of the examples from the homework. All right. So I'm going to find one that has this repeating decimal. This one does not repeat, terminates. This one's a fraction we're converting into a decimal. Fraction that's going to repeat, but we're changing it into a decimal, use long division. Here's one that has a repeating bar, 0.58 bar. So I'm going to call that S equals 0.58 bar. The period is 2. So I'm going to multiply by 10 squared. So that's 100. So I'm going to get 100S equals, and when I multiply by 100, it shifts the decimal point 2 places to the right. So that's going to be 58, now 0.58585858. So 58.58 bar. Subtract the original, And the repeating parts are now on top of each other, 5, 8, 5, 8, 5, 8. When I subtract, I get 99s, 100 minus 1. And over here, 58 minus 0 is 58, and all the repeating stuff canceled out. So when I divide by 99, I get the fraction 58 over 99. Now, this does not reduce because 99 is 3 times 33, which is 9 times 11, 3 times 3 times 11. And this number is not divisible by 3, and it's not divisible by 11. So they share no common factors. It's relatively prime. It's fully reduced. And this is going to be the answer. Right, so over here, I'm going to write, using my fraction bar, 58 over 99. All right, as a final point on this video, I just want to mention square roots. Square root is the number such that when you multiply it by itself, you get that number. And so the square root of 16 is going to be positive 4. Even though negative 4 times negative 4 is equal to 16 also, when we say the square root of negative 16, you're always choosing the primary square root, which is the positive one. And finally, question 40 on here is also about square roots. The thing is that when the minus is outside, you got to think about order of operations. So the top one makes perfect sense. You can take the square root of 25, which is 5, and then apply the minus sign. So this is going to be minus 5. The square root comes first, which is fine, and then apply the minus sign. Whereas this one, the minus sign gets applied first, and then you take the square root. There are no real numbers that when you multiply them by themselves, give you a negative number, because negative times negative is positive, and positive times positive is positive. So no matter what number you choose, when you multiply it by itself, it's always going to be positive. This one has not a real number. So what we're going to do is just put this into the box here. All right, this has been Dr. Vaughn. I wish you well. I hope that I can spend some time with you tomorrow, but if not, I hope that this has been helpful. Please try to have your homework done by Friday, and then we'll go over on Friday a version of the quiz. We're not going to be on Zoom on Friday, just as a reminder. And I'll see you again in Zoom 1 week from today, being next Wednesday. Take care.